Now let's take a look at the so-called range formula. And so this is really just derived from our other equations of motion. So you remember we have x is equal to x0 plus v0t plus 1/2 at squared. And we know that v is equal to v0 plus at. So essentially we have four variables in these equations, right? We have x, we have v, we have a, and we have t. But you'll come across some problems where you don't know what the time is. So there's a way, because we have two equations here, we can get rid of any one variable that we want. And so in this case, we see that it can be really useful sometimes to get rid of the time variable. So if we do that, first we notice that we can rearrange the x equation. So this becomes x minus x0, and that's going to be v0t plus 1/2 at squared. So now we can solve for t in the velocity equation. The reason that we'll solve for it in terms of the velocity equation instead of the position equation is because in position we have a t squared. So it's just harder to solve for t. You could do it that way, it's just more difficult. So instead, we just subtract v0, so we get v minus v0 is equal to at. And that means that t is equal to v minus v0 over a. So now we can take this and we can plug it back in to our x equation. So we get x minus x0 is equal to v0 times v minus v0 over a, right? This is t, plus 1/2 a times t squared, which is v minus v0 times v minus v0 all over a squared, right? So now those cancel out. We can simplify this further. So we say this is v0v over a minus v0 squared over a plus 1 over a times v squared minus 2v v0 plus v0 squared. Right, so there we've just essentially multiplied these two terms in the parentheses together. Okay, so now we can start combining things. We forgot the factor of 2 here, which is important, right? We'll write it out explicitly to show an extra step that maybe you won't do when you're doing this, but it'll make it a little more clear. So we have v0 squared over 2a. We have minus v0 over a, right, because those 2's cancel each other out. We have plus v0 squared over 2a. Right, so now notice that these two terms cancel each other out. And notice we have a minus v0 squared over a and a plus v0 squared over 2a. Right, so those combine to give you a minus v0 squared over 2a. And so that means you have this whole thing, x minus x0 is going to be equal to v squared minus v0 squared over 2a. Right, so now we rearrange this and say v squared minus v0 squared is equal to 2a times x minus x0. And so this is the so-called range equation. And so now notice, if we just have velocities, acceleration, and position, and we don't have the time, we can still solve for our equations. And we'll find this really helpful in the next unit when we start talking about projectile motion.